Welcome all. Let's get started. This is number one. Interest rates, the discount one. There is a connection also. We'll see the connection between these two. And the second one, force of interest. I'll try my best to complete in today's class. Again, the first one, it will take 15 minutes and this will take around 10 minutes. Okay, there are two parts. In second one also, there are two parts. This one is constant force of interest and this is the second one. I'm talking about the second one, that will be force of interest. So this will take another 10 minutes. So I plan this way, 50 minutes is all what required. And of course, it might extend. I'll discuss the concepts here, okay? And for details, you can go through my videos, already recorded videos, in-depth, detailed videos where I solve also a lot of problems. So that will definitely help you. Now, let me start this part one of today's class. If you attend today, I'm 100% sure whatever doubt you will have already, or you must have started just last class, all will be cleared. In case there is any, you can ask me. Even after the class also, you can just write in the comment box. I'll definitely respond. Now, let's start with discount rate. Before starting anything, let me write the important formula. The formula is 1 IP. This is a symbol again. IP divided by P power P. That is equal to 1 plus I. This is the first formula. And the second formula, I discussed about this in the last class. Today, we'll focus on 1 minus dP. That will be part 1 power P, and that is equal to 1 minus D. Even there is a link between 1 plus I and 1 minus D. They are inverse. So 1 plus I will be equal to 1 minus D power minus 1. This one also will use so that you will be able to get any dP from IP or any IP from dP. Also, there is a link between this ID. That's what I've written here. So this box will do. So again, we have to go to the basics here. Now, suppose I deposit 100 here. I get interest 10 after 1 year. If I is 10% and it's simple. It's simple interest rate. Then another 10 here, another 10 here. This is simple interest rate. How about I is 10% compound interest rate? It works like this. This is 0. This is 1. This is 2. And you have 3 here. You deposit 100, you get 10. And on this 10, you get 10 interest. And for this 10, you get another one. So this is 121, right? So if you deposit 100 here, you get 110 after 1 year. Here also 110 after 1 year. The compounding effect starts after 1 year. So you get one extra here. However, the reference point will be this in case of simple interest rate. Okay. So this will be 100, 110, 120, 130. That way it's increasing. However, here 100, 110, 121. Even if you find next time, this 100 will give you 100 plus 10. This 10 will give you 10 1. This 10 will give you 10 1. This one will give you 1 10 paisa. So in total, this will be 133.10. So this is compounding, power of compounding, right? You get money on money, interest on your interest also. That way it grows. So the formula also, if you deposit, let me write here. That way, if you apply the formula, let me draw the line here only. This is a recap because this is required for D. So if you deposit here, after n time period, this is the formula. So if I write here 100 or any amount A, suppose, here after n time period, it will be 1 plus Ni. It's like 140, 1 plus 4i, I is 10%. So let me write n here. This is the formula for simple interest rate. However, for the compound interest rate, this will be 1 plus I power n. That means if you find here any 3 here, if you write A multiplied by 1.10 power 3, definitely you will get this amount, 133.1. Now from here, this is what I taught in the last class, 1 plus A multiplied by 1 plus I power n. Now going here, this is the accumulation formula. And I'm leaving now the simple interest rate. I'll come back to that one. That is equal 1 second. So let's stick to this formula. If you deposit A, you'll get a multiplied by 1 plus I power n. This is one formula after n time period. However, you know another formula that's very, very important. Last time I must have showed you that formula as well. Here what happens if you deposit, but the compounding period is not 1 year. Even I is the interest rate per period, but normally we take 1 year. I is 1 year. I is the rate of interest per annum. So what happens is you compound every year. Normally I'm saying, okay, so I n time periods fixed year. However, if you want to compound 2n times, 3n times, 4n times, n by 2 times, n could be 10 suppose. So what will happen is that means suppose this 1 year you want to compound twice. Okay. So your interest rate will be different, right? I is the symbol we have already considered, we have already accepted that I is the rate of interest, effective rate of interest per annum. But if you take this one, this half year you compound. So what will happen is, suppose for example, n is 10 here. Here 20 times you are compounding. Although n is 10, you have a multiplied by 1 plus I2 divided by 2 power 20 that way. So the number of periods you have to count. Here 10 periods, so we write 10. N is 10 here. Here n is 20 because every year it's counted twice. So you have to make power 20 and a whatever amount 300, 500, whatever you have to write here. And in place of 1 plus I power n, you need to write 1 plus I2 by 2 power whatever period, right? So that way, if you are compounding 4 times a year, so you write I4 by 4 here, and here it will be 40. That way the formula will change. I'm not interested here. Let me write this one. This is what I taught last time. So if I write this formula, single formula, after n time period, it will accumulate to 1 plus I 1 plus IP by divided by P power P. This is equal to 1 plus I and n is there anyway after n time periods. So what I want to say is this one is equal to this one. Even I opened my last time taught PDF. You can see this. This is the formula. So this is the first formula, simple interest rate. And this is the 1 plus I power n. Here 1 plus IP by P is 1 plus I. So you can replace 1 plus I by 1 plus IP divided by P power P. Okay. That way what will happen is your formula is ready. This power n. Okay. So suppose for example, I'll do only one problem. That is the first 15 minutes. Okay. That problem is now you will get everything here. Where to use what? Let me write here. And the second one here. I'll take randomly, suppose 2.5 years, 0, and here 2.5 years. Now suppose you deposited 550 and you want to know the value here. Okay, 550 multiplied by what expression you are supposed to write. It will depend on the question. Suppose you are working in a bank and your bank compounds money after every half year. So of course you take how many half years you have to take, how many half years you need to count. So 2.5 you have. So if you're compounding every half year, so how many half years are here? Of course there are 5. So you write 5. And here half year interest rate you have to write whatever is given. Okay. Suppose I is given 10% in the question and you need to write according to half year interest rate. Then you have to find I2 by 2, I2 upon 2 from I. Okay, the formula you have already, this conversion formula, using this formula, the right hand side formula, this one, you can always get I2 by 2 from I. You just take P is 2 and solve this equation, that's all. So you get I2 by 2 and put here. However, if you want to use I you just write 1 plus I power 5. That's all. 1 plus I power 2.5 because this is 2.5. So this expression is true. This expression is true. Now again, I can write 550 multiplied by 1 plus I4 divided by 4. How many quarters are here? In 2.5 years, how many quarters are here? Of course, there are 10 quarters. So you have to write 10. So it depends. Okay. Suppose in the question I4 is given, you apply this formula. Suppose I2 is given, you apply this formula. For the same problem, if I is given, you can apply this formula. Sorry, this one will be this. It depends. Whatever is given, according to that, you need to apply the formula. Now there is a question. Many ask, suppose even if I2 is given, okay, even if I2 is given, you can always use this formula. What is the problem here? Let me delete everything. Let me delete everything. How I can delete? Okay, as I already said you, I'm also learning how to use this platform. I'm not very sure. Okay, done. So now I'm saying, suppose I2 is given, then also we can use this formula, right? Because there is a link between there is a link between I and I2 divided by 2. If there is a link between I and I2 divided by 2, and I2 is given, you can apply that formula. So the link here, this formula you can apply from I2, you can get I and you can use this. So always you can this formula. You don't need to apply IP by PA3 formula. But then there is a problem. Okay, what is that problem? You will never get this problem in the exam. Okay, this is only your foundation. However, suppose you are solving a long question, okay, pricing a bond or pricing a property, you will be using annuity 20 times there. What will happen is your error will propagate. Now see, for example, uh, I2 is given 4.88%, but this is not exact for I 10%, right? What will happen? Suppose you apply this formula, we are using a calculator will give you 10% and you use here, that will not be the exact answer, the approximate answer you get. So what will happen is the error will propagate, okay? Because for I 10%, we take 4.88%. You take 8 decimal places or 6 decimal places as given in the actual table, but then you are definitely rounding. So the rounding error will propagate. The more steps we do, the more rounding up errors will propagate. That will create a problem. So that's why what you need to do is whatever is given, suppose I2 is given, why not directly use the formula and get the exact answer? Why not use this formula? That's what I'm saying. Whatever is given. See, there are benefits. If you write this way, there are 5 periods. You just use I2 by 2. Sorry. If I2 is given also, you cross multiply and find I2. I2 by 2, not a problem. If I2 is given, you divide by 2, you get I. We are interested in I2 by 2. Okay. So if you can use this formula, what will happen is directly you are putting the value here. You are not using any formula to find. So you are definitely you are you I mean you are doing the right thing and you get the right answer. Okay, that's very important. That way you will have no error. Also, you save time. Okay, when you are using direct formula, you save time. That's very important. Okay, because time is a very crucial factor. You are supposed to answer all the questions. Now, these conversations I'll discuss in another 10 minutes. Before that, before going to the conversion, what we'll do is uh, I'll discuss this one, discount rate. Now, if you see this one, sorry. Let me copy. No, I don't know. Acha, okay. No. Here, 2 here, 3 here. We go this way. If you deposit A here, after 1 year, we write A multiplied by 1 plus I. Okay, if this is half year, we write A plus uh, whatever, like that way. So I'm discussing now compound. Okay, so in that way, I'll write 1 plus I square, because I've taken the full 1 plus I power 3. If you start from here and you want to come this one, suppose you want to get some amount after 3 years, you want to find the present value. Here you are finding the future value, accumulated value. Here you are finding the present value. What will happen is, suppose you want to get A or B, what is that you must have here? B divided by 1 plus I. For that we said BV. This is one way. V, where V is equal to 1 upon 1 plus I. I mean, they are the same. Okay. And here we write BV square, or you write B multiplied by 1 divided by 1 plus I square. This will be BV power 3. The other way is, you can write B1 minus D. So there are two ways. D is discounted rate. This is interest rate. This is discount rate. And then you can write B1 minus D square. Then here B1 minus D power 3. So that way you can also apply. There are two ways. Either you can use V here or D here. There is a little bit doubt all the time. So I'll clarify this in 5 minutes. Then I'll go to the dP by P formula. So consider this one. Suppose you deposit 100 and you are expecting to get 110 after 1 year. Okay. So do one thing. You take a loan of 100 now, and you have to give 10 extra. Okay. Suppose you have taken a loan of 100 from someone, and he's asking you to give some amount extra, which is called interest rate. You are supposed to give 10 after 1 year. However, if the person says, no, I don't need 10 after 1 year, I need exact this round figure. This is what I need next year, 100, because 100 I will use to do something, some work. I don't need 110, 109, 95. I want exactly 100. Okay, do that way. So definitely, what is that amount he will give you, so that that will grow to 100, but this is constant. What is constant? 10% is constant. I 10% constant here. Okay, I 10% constant here. Now the question is, here, this is the amount. If you take a loan, you have to give 10 extra after 1 year. What about this? Suppose you want to give 100. I mean, in other words, the person who has given you loan just now, he says, I'll give you some amount, okay? But I want 100 after 1 year. I want 100 after 1 year. So what I will do is I will discount some amount from you. I will discount. See here, this interest rate is collected. The interest rate is collected at the end of the year. Here, start of the year. That means they say, I will discount some amount from you. But this 10, they are not the same. If you will discount 10 from you, he gives you 90, then definitely it's kind of cheating. Because what will happen is, you deposit 90, I mean, you take a loan of 90, then you are giving 100. This is more than 10%, right? Because 90 should increase to 99. Okay, suppose by chance he gives you 90, then you have to argue that, see, I'll not give you 100. I'll give you only 99, because 10% of 90 is 9. So I'm supposed to give 9 extra. Why 10? Okay, that's wrong. Because you are giving interest here at this time. So it's not 9. It's not 10. That means the time value of 10 here, if you write 10 here, they're not the same. So what you need to do is you have to find the time value of 10 here. That's actually 9.10. That means you are supposed to deduct how much? 9.80, 9.10. That means you have to give 90.90. From where this number came, I'll go to that. So corresponding to I 10%, if you write the discount rate 9.10, so that will be your D. D will be here 9.10%, that is D is 0.0910. So D is applied at this point, at the starting. Okay, that means if he gives 90.90, 90.9, 90 rupees 90 paisa, definitely you will return 100, because you can test it with I 10%. You multiply 90 with 1.10, definitely you will get 100. So same 10%. So corresponding to I 10%, what is D? That is the question. So corresponding to I 10%, D is 9.10%. So you can use either this one or this one. You might ask me a question now, what is the need of this? We can do everything here. Yes, you can do everything using this. However, the situations will come to you while going ahead. When you study more chapters, there you have to use D. Okay. So if something is discounted at the start, you have to use D. So corresponding D you have to find according to I. There is a link between I and D. So how they are connected? This way. I'll write here, and then I'll write here example, the general formula. How it works? Suppose I write 100 here. Sorry, no, I'll do the discount one. I write 90, 90. It grows to 100. You can check it with I 10%. Now, the present value of 100 is this one. You can use this formula, 100 present value, 100 divided by 1.10. This matches with this. Already you must have counted this value. Otherwise, you can check using a calculator. Okay, this value. Now, there is another way also. If you write 100, this 90, you can write this way also. 100 multiplied by 1 minus 9.10, 0.0910. Okay. This is also present value of 100. I can write 0, 1 here, 0, 1 here. So this is also one way. That means this is actually equal to 100 minus 9.10. This is 100 divided by 1.10. So how you write, it depends. Okay. Both are the same. So that means if I write this way, A present value, A divided by 1 plus I, 1 year. A present value, A multiplied by 1 minus D. So they are equal. So here A is equal to this 1 divided by I, let me write. So if you solve this equation, it's a very simple equation. You will get I in terms of D, D in terms of I. What will happen is I will be equal to 1 plus I will be equal to 1 divided by 1 minus D. And if you want, you can find D also. 1 minus D will be equal to 1 divided by 1 plus I. So you can find D. You can find I in terms of D, D in terms of I. So I will be D divided by 1 minus D. D will be I upon 1 plus I. Okay. So I upon 1 plus I. So here, if you want, you can check it. Suppose I is given 10%. D will be 10% divided by 1.10. That will be 10% divided by, and you can find it. This is 9.10. Okay, 1.10. This is 9.10. I mean, D, you will get 0.0910. that is 9.10%. That's all. So you will get D corresponding to I. This is what I've written here. Final intuition before leaving this concept. Now see here. Before leaving the page, let me explain once again. It will depend how you say. Okay, I'm saying in two different ways, because at foundation level, if you are strong, although it's so easy, but yes, you should be very clear here if you are a starter, particularly. Now, what happens is, suppose your friend, she or he went to the market and she said, I got a discount of 5. That means what? I mean, suppose you went to the market with 100, you can say two ways. Okay. One way is, I gave 95 and he says the same asset or same commodity will be 100 next year. So he gave me a discount of 5, saying that this is the present price. After one period, it could be 1 day or 1 year, the price will be 100. You can say this way. You can say this way also. The total price is 100. You can say the total price is 90. You are talking about the total price here. But you can say this way also. Instead of saying the total price, you can say that, see, the price is exactly 100. Okay, the price is 100. He's saying the price will be 100 tomorrow. Say the period is one day in place of 1 year. So the price is 100, he says. But he is saying, because you are taking today, I'm giving a discount of 5. I'm giving you a discount of 5. So there are two ways, right? Either you can say the whole amount. I went to the market and I got a 5 discount. That means rate is 100, but I got it 95. They're the same, right? Or you can say I gave 95 instead of 100. Okay. So when you are talking, whether you are giving the full amount, you are talking the full amount. I mean, this is your subject or this is your subject. See. So when you are talking about this way, that means you are making the discount as your subject. Here the total money is your subject. Okay, so if you are more interested, okay, regarding the discount amount, you say this 5. If you are more interested about the total amount you spent, you say 95. That way. Then what happens is this 95, this we write in terms of this 100 divided by 1.10. That is 1 plus I. And this one, if you take 100 common, what will happen is this will be 1 minus, this is 100 minus 100 I've taken common, so this will be 0.05. Again, in this case, your D is 5%. And if you want to find I here, you have to find from D. Okay, I didn't find. You have to find here. Then you can apply here. I mean, or you can find this way also. You write 95 multiplied by 1 plus I is equal to 100. You solve, you find I. So that way I and D are connected. Okay, now this is 1 year concept. Even in 1 year also, I mean, if you do for 10 days, 15 days, to 2 months, 5 months, you can do that. Okay, but we'll go beyond 1 year. Let's keep it 1 year. We write 1 minus D. Suppose you divide into 2 parts, then 4 parts. What will happen is 1 present value. This is 1. This will be 1 minus D4 divided by 4. If you want, you can write a B also. I've taken 1 unit amount. Then this will be 1 minus D4 divided by 4 power 2. This will be 1 minus D4 divided by 4 power 3. This will be 1 minus D4 divided by 4 power 4. So they are equal. This discounted value once and here 4 times, they are equal. So the formula is this. The formula is If you are interested, I mean, you are starting for the first time, you can do the derivations also. One time, I mean, it's good to know in details. However, most probably will not be needing. Let me write here 1 plus IP divided by P power P is equal to 1 plus I. 1 minus dP divided by P power P is equal to 1 minus D. There is a link between I and D. So I'll do a simple problem and we'll end it here. I know there are some simple interest problems still students are unable to do, but yeah, I have not included those here. Now coming to this one, suppose this is the example. Example is what is given? Given the nominal rate of discount, or even I will not write nominal, I'll write given the rate of discount per annum, convertible quarterly, that is suppose 8%. Question is find half year interest rate. Interest rate means effective interest rate, effective rate of interest, half year interest rate. So how you can use all these formulas? Remember there is a connection between this and this also, because V is 1 minus D. V is 1 minus D. So what will happen is, or directly you can write this 1 plus I inverse is 1 plus 1 minus D, whatever. So in one line you have to do, okay, no more calculations, you what you need, okay. So here in this question you write what is given the rate of discount per annum convertible quarterly, given D4. Remember one important thing for starters, wherever you see the word convertible, if you see a word convertible, that means it's not converted. Okay, here convertible word is missing. That means they're asking to find you I4 divided by 4, I half year, I2 divided by 2. So you have to find I2 divided by 2 from D4. So I'll start with this formula. I'll write 1 plus I2 divided by 2 power 2. I'll write this. That will be equal to 1 plus I from the first formula. And that is 1 minus D power minus 1. 1 minus D is 1 minus dP by P, but given 4. So write 1 minus D4 divided by 4 power 4. So this will be minus 4. That will be equal to, in turn, yeah, I mean, we don't need more. So let me delete this. So here what you need to do is just put the value D4. D4 is given 8%. You put 8% here and solve this. After solving this one, you will get 1 plus I2 by 2 power 2. Then take 2 this side. And then, I mean, subtract 1, multiply by 8, whatever, those algebraic steps. And finally, you will get I2. Okay. We need I2 by 2. Okay. We need I2 by 2, whatever. So this is a simple question. I just showed you. Okay. So you need to solve plenty of questions. I think I solved around 20 to 30 questions. We have around 50 problems on interest rates. But yeah, I tried to do in 1.5 hours. Last time 1 hour, this time half an hour. It's a kind of revision. I'm sure this is something for the starters, this is not sufficient. So I recommend you, if you are a newbie starter, you just started studying interest rates, so you solve plenty of problems, around 50 problems. So even I solved, I think I had a last like 3-4 years back, I uploaded videos, around 10 videos for interest rates. All those 10 videos you have to do so that you will feel confident. Okay. Now let me go to the last part of this chapter, that is force of interest. Now, what is force of interest? Let me start from here, then I'll give you example. You will not see the banks or financial institutions, they apply practically force of interest. However, yes, in our subject, we use, even practically also it's used in the contract, but not, I mean, you will not see the practical use outside where you deposit or save money. Now what happens is, suppose you have these periods. No, this one will be 1, right? So what we'll do is, we'll delete it. How? We'll make it this way. I can copy paste also, right? So this one and then this one. So how many? 4 we have. Another will make it. So more times compounding. Then what will happen is, again we can divide into 2 parts. I don't know why I'm using different symbols here. You compound this way. What will happen is, you have to divide this also into 2 parts. Like this I have divided into 2 parts, these 2 parts. This also you divide into 2 parts. This one also you divide into 2 parts. This also you divide into 2 parts. So this way if you do, then what will happen? When you are drinking water, how you drink water? How you drink water? See, it's like this. In 1 hour, I here and here, these are the 2 points. Okay, you can drink. You can make 1/4. You can make every 15 minutes. You can drink every 15 minutes, then half, then half. You can continue that way. Then continuously have to drink. The glass is there, okay? And glass or bottle, whatever you have, you are drinking. That's all. Okay, that is continuous rate of interest. But in terms of finance, actually, what will happen is, here they have 2 periods. That means they will compound. It used to be before, for 50 years or 40 years, it used to be like this. Suppose you deposited some amount, okay? They had to calculate after 1 period. Suppose if I take period half a year, so half year, the calculation is, suppose I is 10%, according to that. Of course, here I have not taken I. You can take I 4.88 or I 10, this half year interest rate 10%, whatever way. Okay. I'll write symbol in instead of the value, let me write the symbol here. So what happens is, here I have to write 100 multiplied by 1 plus I2 divided by 2. Then you write 100 multiplied by 1 plus I2 by 2 power 2. Just because we have 2 periods, this is 1 period, power is 2. This coefficient is the amount, and I2 by 2 is the interest rate for this period. This is our symbol, that's all, nothing more. How about this? You have here and here, 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 here. If you see here, how many times? Here twice, here 1, 2, 3, 4 times. So you have to write power 4. So here basically I'll write I4 divided by 4 power 4. That way, if you continue, a time will come. So suppose here I will write 1 plus every day. You compound every day. You don't have any work. What you can do is, you go recalculate money here. Okay. Whatever you calculate here, you deposit 100. At the end of the first day or the start of the next day, you count money here. Then again you compound. You give some little money instead of more money. It's like your father is giving you yearly amount to spend, or your father is giving you every day, that way. So little amount you have to add. So that way, from uh, everyday compounding daily, you can go to compounding 1 hour, then compounding every second, then compounding every moment. So physically it's like this. Suppose you are standing there, you are a customer, and I'm here, I'm the part of the company or the bank. uh, I'm sitting in the counter. I'll give you money here. Continuously be taking money from me. Continuously. There is no discrete here. So because I'm giving you continuously money, you have to stand there and physically have to take continuously money from me. So what will happen? In that, it's like drinking water continuously. So if you deposit 100 here, okay. So even if you consider second, what will happen? It will be 1 plus. This is 1 hour. 1 hour. Sorry, 1 day. 1 hour multiply by 24. That will be 1 hour. Then 60 multiplied by 60 divided by 60. I mean, hold this. Every second you are compounding here, and this power also you have to write whatever number. Okay. This is 365. Sorry. So this will be a big number. So this is going very bigger and bigger. Okay. So if you are not from math background, remember this is not there in our course, the derivation, but the formula is there. Let me write the formula here. Before that, I need to delete this. So instead of 1 second, I'll make it half a second, quarter second, millisecond. Then I'll go to every moment. Then what will happen? This will become E delta. You can say E power delta. Mathematical, that's not true, but it's okay. Let me say you E power delta. Okay. So this E power delta is approximately equal to this. That is approximately equal to this one. That is not quite approximate, but yeah, close to this one. So because you are finding at the end of 1 year, okay. So this is approximately equal to this or exactly equal. That you need to know. Exactly equal when mathematically when you find that will be exactly equal. When I say approximately equal, I am saying every second interest rate. Okay, every second interest rate, if you find that every second, every moment, they are very close, I am saying. That way approximate, but mathematically you will get equal answer. Okay, because E power delta, because there is a conversion. Delta will find according to I. The formula is this. Let me go here. If there is a confusion, let me write here 2s. This was a part of the derivation. I'm talking about the derivation. The derivation was also a part of the course long before, I think prior to 2015 or 2012. I don't remember exactly. If you deposit here, it will grow to E power delta. Here, the compounding is continuous this way. If you compound 4 times, you know the formula. If you compound 1 time, you know the formula. Okay. You deposit 1 here. This is 1 plus I. So what will happen? They are equal. E power delta, that is 1 plus I. That's all. You can extend to the next year. If you extend to the next year, it will go this way. After 2 years, you can write E power 2 delta, and this will be 2, 1 plus I square. But the main one is this E power delta, that is equal to 1 plus I. Okay. So if delta is given, force of interest, I explained already force of interest last time. What is the meaning of delta? Delta is the rate of interest, the nominal rate of interest per annum, convertible every moment. Okay. But this is not your yearly interest rate. You remember this one? If I is 10%, roughly you remember, your half yearly interest rate equivalent to this is 4.88%, and your quarter interest rate equivalent this is 2.41%. Oh no, I'm not interested in this. Let me write the nominal ones, because delta will not come here. So let me write I2. I2 will be 4.9 point multiply by 2, 4.88, that is 9.64. 76. Then I4 will be 9.64%. I don't remember you find I365. This is convertible every day. How you can convert? Just divide by 365. This is before conversion. That will be 9.531, something like that. So if you find delta, okay, that will be 9.53%. All are per annum. So I is the rate of interest per annum. I2 is the rate of interest per annum convertible half yearly or compounded. If you are doing from SOI, there we use compounded half yearly. That means you can uh, convert it to get half yearly interest rate. According to IFO and India, it's I2 divided by 2. And here I4 divided by 4. And you convert it to everyday interest, you divide by 365, but you can't convert this to every moment because infinite, you can divide by infinite, right? This is every moment. So you know only nominal. On the basis of nominal, you have to solve problems. It's exactly saying if someone will ask me at what speed you are driving, I can say I'm driving at a rate of 40 kilometers per hour. When I say I'm driving at a rate of 40 kilometers per hour, this means what? This means I'm driving, I can say at what rate at this instant, but if I continue to drive in the same speed, I will cover 40 kilometers in 1 hour. That's what I'm saying. This is constant. I mean, on a road where there is no traffic and there is no friction, you can travel at a constant rate of travel at a constant velocity or speed, you can say. Okay, that will not change. But on a road you are traveling, mean that will be, I mean, it will be up and down. Okay, there will go to force of interest. This is constant force of interest. Now let's go to the general formula. The general formula is this. Oh, where this came? The general formula is this. If you deposit here, suppose you deposit 100 here, or you can write A if you want, or unit 1. This should grow to 1 plus I anyway, we know that. I'm interested here. E power, suppose you write 0 to n, or A to B if you want, you can write. This is the formula actually, okay, delta t dt. Now I'll talk about delta t. What is delta t? This is force of interest. Now suppose there is no variation. Suppose I will write this way, delta t is equal to, for example, I will write 10% and there is a variation of this 0.001 t. This means what? Let me write. This is delta t. This means what actually? See, your delta is changing. Okay. How delta is changing? I'll write here what is the interest that is applied here. What is the interest that is applied here? What is the interest that is applied here? What is the interest that is applied here? Okay. Now see how it's changing. Just take T1. If you take T1 here, this is 10.1%. See the interest rate is changing. Okay. Suppose you are driving a car. Okay. So you are increasing your speed, right? Here in this example, I am saying. It could be minus, it could be 1 by. There are so many functions. This I am saying. Here it's 10%. Okay. Delta is 10%. Here delta is 10.1%. Okay. And also in between also, if you want, you can find. It will not be 10 or 10.1% because at every point, at every t it's changing. At every t it's changing, right? At 2, your force, your interest rate applied is 10.2%. It's exactly like you are driving, right? So, and here, if you take this is 10, what will happen? You multiply by 10, 10 that is 0.1. This is 0.1%, right? So that will be 1%, so it will be 11% this way. If I write minus here, your interest rate is decreasing from time to time. Okay, roughly I can say if you deposit some amount here, how it will grow without using any mathematical formula. However, if there is no such variation here. This is no more there. So you just take 10%. So that way what will happen? If delta t is constant, you write delta because it's constant, there is no change. You integrate it and you will get e power n delta. This is the normal formula after n years. After 1 year, 1 delta, after 2 year, 2 delta, after n year, n delta. But this is the general one that is called force of interest. Okay, where suppose you are traveling by a car and you are traveling at various uh, speeds, that will be captured here in delta t because there is a function of t. With time, your delta is changing. Okay, then you have to use this formula. If you are finding present value also, you just write a -1. That's all. So these are the two formulas you have to use. Better let me do a problem here. And with this problem, we'll end the class. It's already 7. 1 minute more. Next time, I will start annuities. Because you have a target, you can help yourself by following those videos already I provided or wherever possible. Suppose 5 years. I'll write problem like this. Mr. Amit deposited this is 200. You have to find the value here at time 5. Find how many years? 5 years I have taken. Find the value you must have received on 1 January. You add 5 years, that is 2015. That's all, 5 years. In 3 cases. First case is I is given for you. You can write 5, 7, 10%. In the second case, D also you can take, but I'm not interested in that. Delta is given. And in the third case, delta T is given. So suppose this is 10 is given and this is something like 0.11 minus 0.002 t, whatever way, it will be a function of t. So the first one is simple. After 5 years, this will be 2 multiplied by 1.07 power 5. And if you are using this formula, it's very simple, right? You write 200 here and then 200 multiplied by e power 5 delta. You put the value of delta here. That's all. How about this? You have to integrate. You write 0 here, 5 here, 0 to 5. Just write delta t dt and you need to integrate this one. And if you don't know integration, you are not from math background, I have 50 math videos, recording videos already. If you ask me uh, in comments, I can help you. However, ultimately it's a business course, but the base is mathematics, so you will be needing. You don't need all 11, 12 mathematics. So mathematics level is required, but along with clearing papers, the higher ladder you go, the more applied mathematics you will learn. So in CM1, you will be learning some math, in CS1, some math. So if you don't know, you have to know statistics like random variable, what is the real meaning, how you can apply to practical situations. Little bit you have to know what is mean, variance, kurtosis, skewness, all those. And coming to the algebra, minimum calculus, differentiation, integration, all this you need here. And of course, at a higher level, when you work, a lot of statistical techniques you must be knowing. Okay. All right. I planned 2 classes and I think I've completed in 2 classes, not completed properly, but yes, I wanted to complete. I wanted to just revise. Okay. Uh, for any kind of help, if you want, definitely you can ask me. Another thing, suppose delta t is given this way, 0.05, 0 to 2, then 2 to 5, or write 0.08 minus 0.0070, whatever, some interest rate, and t greater than equal to 5, I can write 0.007t square or square root, whatever you want, you just write it this way. Okay. Then if you deposit amount here at 0 and you find the value at 10, how can you find? You just divide two fives after 5, right? You make a point 2 here, 5 here, 10 here. So whatever amount is deposited, for this part you can use this 0.05, and for this part you can use this formula, and for this part you can use this. That's all. So from here to here you find, from here to here you find, here force of interest, constant force of interest formula, you can write 2 delta, or you can use the general formula as well, not a problem. This one also, this one also. That's all you need to do. Nothing more here. But ideally you are supposed to complete the interest rate part, but fortunately for you, delta will not use much. The important thing is IP by P all the time. You will not understand annuities if you don't know IP by P, DP by P. So what I left is simple interest rate I didn't teach. Okay. So this one you have to do yourself. And if you want to join live from annuity class, you have to complete this before the next class. So as I already mentioned you, live classes I don't do much. Okay, so there is no comment, right? So I'm leaving now. Thank you.